Okay, back to the axis of symmetry. If you look in the picture, what I have is this picture has 1, 0. You can see it crosses right there at the x-axis in one spot. However, this one has 2 zeros. It crosses the x-axis in 2 spots. The axis of symmetry always passes through the vertex. The vertex happens to be the 0 in this problem. The vertex in this problem happens to be the x value that's between the 2 zeros. So you can actually use the zeros to find your vertex, or to find your axis of symmetry, not find your vertex. If you look at the zeros and you average them together, or if you only have 1 0, then you know that that has to be your vertex, which is also your axis of symmetry. So what we're going to do is we're going to quick look at just a couple more problems. We're going to find the axis of symmetry on both of these problems. Again, the axis of symmetry, this one just has 1 0, and the 0 happens to be at -1. So my axis of symmetry also has to be x equals -1. This one has zeros of 1 and 4, and so my axis of symmetry is a little bit more difficult to find because it's not exactly right there. But I do know that my zeros are 1 and 4, so if I average those together, so if I take the 1 and the 4 and I add them together and I divide by 2, I will find out that 5 halves, or when x is equal to 2.5, or 5 halves, that's where my axis of symmetry lies. The next thing I want to show you is that sometimes it's very difficult to find the axis of symmetry. So we're going to use this formula, and the formula is -b all over 2a. And so we can use this formula to find the vertex and the axis of symmetry for quadratic functions. Notice how I don't have a picture on this problem, so it's going to be hard to find the axis of symmetry without that formula. So we're going to go ahead and use it. X equals -b all over 2a. Here is my a value, it's the one with the x squared. Here is my b value, it's the one with the x. And so all I'm going to do is simply plug in those numbers. I have -10 over 2 times -3. And then I'll just simplify this. You get -10 over -6, and that does reduce. So we'll go ahead and write our final answer as 5 over 3. Let's try another one of those using the formula. X equals -b all over 2a. Here is my a. Here is my b. Notice it's a 1. Okay, there's nothing there, but there is something there. So we'll say x is equal to -1 all over 2 times 2. So that means that my axis of symmetry is x equals -1/4. Continuing on, as a reminder, so this is standard form of a parabola, y equals ax squared plus bx plus c. When we have it in standard form, we can pull out that a and that b term, which is going to help me find my vertex. Now remember, the vertex always lies on the axis of symmetry. So if we find the axis of symmetry using that formula, we also know that that's going to be the x-coordinate of our vertex. After we find that x-coordinate of the vertex, we can take that number, whether it's 3 or 1/4 or anything, and we can substitute it back in for x to find y. Now we're going to go through that whole process with a few different problems, so you're going to see this many, many times. So let's try to fit one in here. We're going to go ahead and say we're going to find the vertex, and then we're going to find all of these things as well. So the vertex happens to be x equals -b all over 2a. Again, here's your a, here's your b. So the axis of symmetry ends up being -6 all over 2 times -3. Okay, and I'll come this direction with it. That gives me -6 over -6, which is a 1. So my axis of symmetry is 1. Knowing what we know about axis of symmetry, that means my vertex is 1 comma something. The way you figure that out is by taking your 1 and plugging it back in. So we can find the y value, so we're going to plug 1 up here. And we end up getting -3 plus 6 minus 7, and I'm going to have to finish this up on the next video.